In this lecture, I will study about introduction to fracture mechanics. First, you know what is the definition of fracture mechanics. So, fracture mechanics is a field of mechanics concerned with the study of propagation of crack in a material. In general, so fracture mechanics gives details about the propagation of a material, means it is related to the crack in a material. So this method of means fracture mechanics method of analytical solid mechanics to calculate the driving force on a crack, and those of experimental solid mechanics to characterize the material resistance to material. So in this case there are two method. One is your analytical solid mechanics, one is your experimental solid mechanics. For analytical solid mechanics to calculate the driving force. In experimental solid mechanics, you have to calculate the material resistance to fracture. But in modern material science, fracture mechanics is an important tool used to improve the performance of of mechanical components. Another definition is fracture mechanics is the mechanical analysis of material containing one or more cracks to predict the condition when failure is likely to occur. It is an important topic for many reasons and is used to first one design aircraft structure and select material with high resistance against cracking. So first one is now whenever you should design aircraft, then this analysis is used. Second one is calculate the residual strength of the aircraft structure containing crack. Third one is to determine whether a crack is big in and does not affect the strength of an aircraft structure, or whether the crack may lead to complete failure and therefore the structure must be repaired or replaced before occurs. Fourth one is your determine the cause of structural failures in aircraft accident investigation, means if any accident arises in aircraft then it can determine also. Fifth one is minimize the need for expensive structural test on large aircraft component to assess their damage tolerance and residual strength. Many analytical methods are available to calculate the fracture strengths of containing the crack. So generally there are two methods. One is your LEFM, second one is EPMF. LEFM is linear elastic fracture mechanics is generally used for brittle material, and elastoplastic fracture mechanics is generally used for ductile material. Then what is the meaning of fracture? Then come to the fracture. So fracture means what? Who can tell me? Now fracture means it is a separation of an object or material into two or more pieces under the action of stress. For example, this one is your material. If you give some force, if this load will be more than this material, then it start to break, then this material starts breaking. So fracture is a separation of an object or material into two or more pieces under the action of stress. Second one is the fracture of solid usually occurs due to the development of certain displacement, discontinued surface within the solute. Means if body or surface having discontinuity, then fracture generally must be taken. So next one is your basic modes of fracture. So generally there are three modes of fracture: mode 1, mode 2, mode 3. Mode 1 fracture is known as opening mode. Mode 2 fracture is known as sliding mode. Mode 3 fracture is known as tearing mode. So see your three diagram. This one is a diagram 1, mode 1, mode 2, mode 3. Three figures are represented here. So in mode 1, or you can say opening mode, this one is your mode 1 or opening mode. Here what happened? Now in this case, tensile stress normal to the plane of the crack. So this one is your tensile stress which is acting plane of the crack. Means what happen? Mean whenever a tensile load acting, then the cracking will be like this in this direction. Crack will take place. But in mode 2 or sliding mode, or you can say in plane shear, a shear stress acting parallel to the plane of the crack. So this one is your C second figure mode 2 parallel to the plane of the crack. So this one is your arrow mark which is parallel to this crack and perpendicular to the crack front. Perpendicular. So this one is your crack front. This one is your crack front perpendicular to the crack front. So it is one type of sliding means this one is your body. If some loads are here then it becomes like this. Then mode 3 also known as tearing plane or out of the plane shear. So in this case, shear stress acting parallel to the plane of the crack and parallel to the crack front. So this one is your mode 3. This one is your parallel to the crack and parallel to the crack front also. Means tearing takes place. Means first one is your shearing means in this one is your mode 1 opening mode, then this one is your sliding mode, and this one is your tearing mode. One material is here, another material is here, then the material takes place in this side, left side or right side. This one is your tearing mode. So mode 1 is the most common in all engineering material. Mode 2 is dominant only in fiber reinforced composite. So you just remember mode 1 is basically used in all engineering material, but mode 2 practically fiber reinforced composite. So next one is a type of fracture. So generally there are two fractures are used. One is your ductile fracture and other one is your brittle fracture. So generally there are two fracture. One is your ductile and other is your brittle. So first one is your ductile fracture. So ductile fracture is a type of fracture character, characterized by extensive deformation of plastic or necking. Means ductile fracture is used when there should be some plastic deformation or necking takes place. Means it beyond the yield point. So second point is what? When a ductile material has a gradual increased tensile stress, it behaves elastically up to a limiting stress and then plastic deformation occur. As stress is increased, the cross-sectional area of the material is reduced and a necked region is produced. With a ductile material, there is a considerable amount of plastic deformation before failure occurs in the material. Means, so it follow the stress strain diagram for what? Stress strain diagram for which material? Ductile material means mild steel. This one is a stress, this one is strain. So this is a straight line, elastic region, then this one is your plastic region, ultimate breaking. Means the here the deformation takes place. Means necking will be there. So it is a ductile fracture. So there are steps in ductile fracture. There are four steps. One is your necking, first one is your second one is small cavities formation, third one is your formation of crack, fourth one is your cup and cone fracture. So, so this one is your first figure. So whenever a force applied means tensile loads are acting, then necking formation. See the figure. So neck should form here. Then in second figure, whenever you apply more load, then a small cavity are formed inside the member. Then stage 3 formation of crack. Again you applied 4, then here formation of crack. See the figure, this one is. Then finally the fracture takes place. So after that the surface become cup and cone type of structure. Mean upper one is your cup, lower one, sorry, upper one is your cone, lower one is your cone type of structure. Then second one is your brittle. So brittle fracture means here there will be no yield point. No yield point takes place. So brittle fracture takes place without any appreciable deformation, not permanent deformation, or by rapid crack propagation. The direction of crack motion is very nearly perpendicular to the direction of applied force or applied tensile stress and yields a relatively flat fracture surfaces. When gradual tensile load is applied on material in tensile test, at the end of elastic limit without any prior indication, material breaks. In this type of fracture is called brittle fracture. So this one is known as brittle fracture. Means you draw a curve that is the stress strain sigma epsilon for brittle material, for example cast iron. Means this one is your breaking, this one is a straight line. Then after that some plastic stage will come, then break will start. Means here there will be no ill-point, means there will be no necking takes place. Here no necking takes place. Next one is your what is the difference between ductile fracture and brittle fracture. So ductile fracture and brittle fracture, in first point, in ductile fracture large plastic deformation occur, but brittle fracture there will be minimum plastic deformation or less plastic deformation. Second point, it always preceded by localized deformation or called necking. Means in ductile fracture necking is formed, but in brittle fracture there will be no necking. Third point is ductile fracture normally occur in FCC metal, means face center cubic metal, but brittle fracture normally observed in BCC and SCP. BCC means body center cubic, SCP means hexagonal closed pack. No, 4 point. Ductile fracture normally occur through the grains. Brittle fracture normally follow the grain boundary. Then fifth number point. Fifth number point. Surface obtained at the fracture is dull or fibrous in appearance, but surface obtained at the fracture is shining and crystalline appearance. The appearance should be, or the surface after cracking should be good, or it looks shining in nature. Number 6, in ductile fracture, reduction in cross section area of the specimen means necking. Necking means reduction in cross section, but in brittle fracture there will be no change in cross section because there will be no necking takes place. So last point is the tendency of ductile fracture is increased by the dislocation and other defect in meta, but in brittle fracture the tendency of brittle fracture is increased by decreasing temperature and increasing strain rate. Then fracture affecting factor affecting fracture. What are the factor affecting fracture of a material? So there are in general 4 factors are there to affect the fracture. First one is your stress concentration, second one is your speed with which the load is applied, third one is your temperature, fourth one is your thermal shock loading. So these are the different factor in which can affect the fracture.